This video is about waves, and this question is from October-November 2014, paper 23, question 7. Question A, explain what is meant by a progressive and transversive wave. Answer progressive wave in terms of energy, and answer transverse wave in terms of the particle motion. Wave energy is transferred from one place to another. A transverse wave, particles in the wave oscillate at right angles or up and down to the direction of the wave. Next question, define frequency. It's the number of waves per unit time. Question B, the variation with a distance x of displacement y, distance x, displacement y, for a transverse wave is shown in figure 7.1. On figure 7.1, 5 points are labeled P, Q, R, S, and T. Use this figure to state any points having a phase difference of 0 and 270 degrees. Phase difference can be determined between two waves and also a single wave, but when you have a situation with a single wave, we have to look each point on the wave and compare in that particular point, what the particle is doing, and compare the motion. Let me hypothetically state this wave is moving in this direction. This red dotted shade represents the shift of this black line wave in certain time as is moving in this direction. To spot the motion of the particle in the wave at each point, so I'm going to connect those two waves using arrows. For example, here at point P, I'm going to draw a wave, and the tip of the arrow is going to be connected to the shift of the displacement in this direction. Likewise, at Q, drawing this arrow, at R, this arrow, and S, right here, this arrow, and at T, this arrow. So it's safe to say the particle at point P is going up, at Q down, at R down, S up, and T up. So here is what's happening. Particle at point P and at point T are doing the same thing. Particles here, they are moving up because they are doing the same thing and they are located at the same spot. Right here at the trough, we can say the phase difference between particles on these 2 points is 0. So here is at point P and T. Okay, now the phase difference is 270 degrees. Remember, one complete cycle, let's start point here to this point corresponds to 360 degrees. If I'm looking 270, I have to deduct 90 degrees. So it will be like 90 degrees or a quarter, 90 degrees or a quarter, and 90 degrees another quarter. So 3/4 of those pieces makes 270 degrees. Let me start with P. So I need to find three segments of this wave. So 1, 2, 3. So right here, we can say the P and S. The phase difference is 270 degrees. Is there more? Let's look. If I'm going to move it to Q, let me count. So 1, 2, 3. So also I can say that the particles at point Q and T, they have a phase difference of 270 degrees. It's way easier to observe when you draw the shift of the wave as is moving in one direction. Next question. The frequency of the wave in B is 15 Hertz. Calculate the speed of the wave. That is just one formula for the speed of a wave. So speed of a wave in terms of the wavelength and frequency. Frequency was provided, but we need to observe the diagram to find the wavelength. These are two troughs. So this is one complete wavelength. This is easier to find the corresponding number on this X. So here we have, right here is 1.6 and this is 2. So it's safe to say here is 1.8. And at P, this is 0.4 and this is 0.8. So it's safe to say here is 0.6. So the wavelength is 1.8 minus 0.6, which is 1.2 centimeter. But the unit here is in meter. So we need to convert this to meter by dividing by 100. So the wavelength is actually 0.012 meter. Back to the formula. So V is 0.012 times the frequency. So V is 0.18 meters per second. Question D. Two waves at the same frequency have amplitudes 1.4 centimeter and 2.1 centimeter. Calculate the ratio of the intensity of each wave by the given amplitude. So the intensity is the amplitude is square. 1.4 is square divided by 2.1 is square equal 0.4. No units. It's cancelled.